Hello and welcome to this repair tutorial, and today we're going to look at a Marantz and the model number is PM and this is the 7200. In terms of general specifications, power output in class AB mode is 95 watts RMS and that's 2 times 8 ohm speakers. Via the front push buttons you can select class A mode, then this will go to 25 watts per channel RMS, again into 2 times 8 ohm speakers. You have the ability to have 2 sets of speakers connected, so system 1 and system 2, again selectable from the front. You can also bypass the tone control circuits by selecting source direct mode. And frequency response is 20 Hz to 20 kHz. Total harmonic distortion is 0.03%. And it accepts a moving magnet type cartridge input from a turntable, and this is 2.5 millivolts. And then for all of your other line inputs, it's 150 millivolts. Dimensions 440 by 159 by 275.4 millimeters for width, height and depth. And the amplifier is fairly heavy at 12.3 kilograms. You can also connect directly your headphones for private listening, and you also have a record output as well. The amplifier also supports a remote control, so it would have been provided with a remote from new. So what was the issue with this amplifier when it came into the workshop? Well, the owner of the amplifier reported a similar issue which is seen, and it's always age related. So this is where intermittently one of the channels may well sound distorted, or there would be intermittent sound loss. And then by increasing the volume control, sometimes it would override it and then the sound would come through. And you kind of had the same effect in class AB mode as you did in class A mode. And as I said, it is age related, but we'll sort of get into that in a moment. There was one other fault as well, which was only identified during the final test phase. And I'll go in detail with regard what the issue was and how we resolved it. Now, when the top cover is removed from the amplifier, maybe if you were the owner of the amplifier, this looks a little bit alarming because everything is covered in a very, very thick layer of dust. But this is completely normal. Because of the amplifier generates substantial amount of heat, and you can see the large power output heat sinks here left and right, you have ventilation slots on the top case, and of course the dust over a period of years just falls through. So part of the service and repair is to remove all of this dust. The good thing is it didn't come from a humid environment, so this layer of dust wasn't stuck to the circuit board and there was no signs of liquid damage or anything like that. Now on this photograph what we're showing you is the amplifier underneath, and it's mounted vertically. And what I'm drawing to your attention is that these amplifiers have a service hatch, and what you have to do, and what has been done here, is these metal sort of tabs are just cut and then the screws removed, and then you have access then to the amplifier board. Now the owner of the amplifier did advise that previous work had been carried out on the unit, but then the fault tended to reappear. The issue always is related to dry solder joints. By just taking care maybe of this amplifier board here, you have all the issues associated with the input boards and also the microboard, preamplifier board, etc., and also the power supply. So it's really a systematic approach that you have to take, where you have to re-solder all of the circuit boards. You also have to replace as well the speaker protection relays, and we'll sort of go through that. And then here what you can see is the rear panel. What I'm drawing to your attention is on the left hand side where you see the RCA input sockets, you can see these metal links. Now those must be in place if you're going to use it as what I would term as a fully integrated amplifier. If you remove the links, then what you're able to do then is to connect the amplifier maybe to another preamplifier if you wish. The serial number of this amplifier is also important as well, because that will link to a particular problem later on in this repair tutorial. Just be aware also as well, there is a common ground connection on the speaker terminals where you have the copper type fixing screws. You don't want to test this amplifier after repair without reinstalling the back panel, because it has the common ground connection. Now, the first circuit board that we're going to look at is this one here. So this is the main input selection circuit board. And you can see your RCA sockets and those red components there. There are 13 of them, and these are small signal switching relays. And what you'll find on this circuit board, as you see here, is that there will be multiple dry solder joints on every single connection pretty much. But what I've done here is I've just drawn circles around the most common ones. And wherever you get mechanical stress, and also with this series of amplifier, a lack of solder, you're going to find dry solder joints. So you have to just be systematic, as I said, work your way across the circuit board and re-solder all of these connections. Some of the connections as well are very close to one another, so just make sure that you verify your work and you don't accidentally make a solder bridge. And then on this circuit board, this is the piggyback board. You just have to disconnect it from the main input board. It's just via a multi-pin connector and a plastic standoff. And again, when we look here on the underneath side, you can see all of the different dry solder joints. So RCA sockets, all the connectors, everything has to be resoldered. Now, on this photograph here, at some point in time, the amplifier maybe got exposed to a damp environment, or it was in some storage, maybe in a loft or an attic. What we do here is we just sort of remove as much of this rust as you can, and then just put an anti-rust agent on top of there just to make sure it doesn't continue further. But normally if it's in a dry environment, you shouldn't sort of see any further issues developing. And then when we look here, what we're showing you is the underneath of the main amplifier board. Now this circuit board will be covered in dry solder joints throughout. Just take your time, you can disconnect it from the main chassis and just work your way across that circuit board. Just look very, very closely, you'll see all the cracks around the component joints and everything needs to be resoldered. Because of the age of this amplifier as well, what we did was we just removed the fixing screws for the power output transistors, and you can see them here. And what we're doing here is we're wiping away the old heatsink compound because it had really completely dried out. There was also quite a lack of heatsink compound on the rear of these micro washers. So this was cleaned off and then brand new compound put onto the back of the power transistors and then also on the back of the micro washers where they fix directly to the heatsink. And that just really makes sure that the driver transistor, the small transistor and the power transistors are getting the maximum heat dissipation that they can, and it just improves the overall thermal stability and also performance, i.e. the transistors are not running excessively hot and struggling to get rid of that excess heat. The other circuit board is the vertical board which is plugging into the main amplifier board, and this is it here. This is your speaker protection board, and you have a dedicated integrated circuit and then some timing components. And when we spin it over, again, what you're going to see here are these dry solder joints throughout. So you have to resolder every single one of those. The next circuit board that we look at is the large power supply, and we're looking down on it here. So you can see that this is the chassis, main amp board has been removed, input selection boards are removed. Now, on the right hand side, you can see two large canisters. These are the main power supply electrolytic smoothing capacitors. Now, please be aware that these capacitors will store a huge amount of energy. So what I do here is once I disconnect and unplug all of the different cables and then remove the fixing screws, I can lift up this circuit board. But what I use is a capacitor discharging tool just to ensure that any residual current is then dissipated. Because the last thing you want to be doing here is maybe you're looking at resoldering some of the dry solder joints, or maybe you accidentally move the board and it makes contact, say, with the metal frame. It will cause a lot of damage to the circuit board as the capacitors discharge, and pretty much it'll sort of weld itself to the chassis if that's what it makes contact with. So it's a little bit of extra time, but once you discharge the capacitors, then you'll be confident then that you can handle that board freely and you're not going to have, a massive discharge of energy when you don't need to have it. And then here on the circuit board, when we turn it over, again we're highlighting points. So there's a voltage regulator and also a number of rectifiers. And then you've also got the remote control RCA sockets and the rear. And again, these will have all dry solder joints. Another area is where you have the larger components as well, including the large power supply smoothing capacitors. So just work your way across that circuit board and then resolder them. Because this amplifier can also run in Class A mode, what you have is this relay here. And this is a power relay. What you need to do is you need to desolder that relay. And then what you're able to do is to remove the top cover and then use a fiberglass pencil and clean off the oxidization from the switching contacts. What I would advise you not to do is to use something abrasive. So here, as I said, fiberglass pencil, some De-Oxit, just lightly brush across and you'll remove all the oxidization. There wasn't any pitting or anything like that. And what this relay is doing is it's just switching in a lower voltage winding from the transformer when the amplifier is in class A mode. So the higher voltage is when it runs into class AB mode. So once these switching contacts are clean, I can then put the top cover back on and then put it back into the circuit board. And then when we're looking down from the top, what I'm highlighting here is a couple of boards. The first one immediately in front of you, what you can see there is the volume control potentiometer, and it's a multi-gang pot. The motorized mechanism with its gearbox. And then you can also see as well the voltage regulators on the board beneath. This is where you have your tone control circuits. And what you will find is that there will be multiple dry solder joints. So again, here, when we look at the volume control circuit board, I've drawn circles around all of the different bad solder connections. So it's a little bit sort of long-winded. You know, this isn't something you can do in half an hour because you have to remove each board, clean it, inspect it, and then do the soldering. But if you follow along from the tutorial and just make sure that you're checking your work as you go along, you should be rewarded with a good outcome at the end of it. And then here for the tone control board, what you'll find is that there will be dry soldered joints on the voltage regulators and also on the balance, treble and bass control potentiometers. And then here, what we're showing you, this is the headphone socket. And again, you'll find that there's dry solder joints underneath there. And this also supports where you have the speaker set 1 and speaker set 2 switches. So again, you'll find dry solder joints around these multi-pin switches. So you need to reflow them. The next area which we're sort of going to focus on is this area here. So this is an extract from the service manual. And as you can see, we are highlighting the microcontroller. And this is a 4-bit in the early versions of this amplifier, micro. And you can see the various inputs and outputs plus the clock. Now, when we look from the top, this is the main microprocessor here. And then all of the associated switching transistors and the LEDs. When you were in a test phase, so all of the work had been completed, you could probably run for about 20 or 30 minutes. And then what would randomly happen, you'd sort of just catch this, is that all the LEDs on the front face would just illuminate, and then the amplifier would effectively just go into protection mode. But if I cycle the power on the amplifier and turn it back on again, it would run again maybe for another half an hour or so. So what I do here is I'm just checking, making sure that everything is correct, and the microprocessor appeared to be working correctly, and then it would just stop. So that's kind of indicating that there was no external things which were coming into the micro which was causing it to do that. And the fact that all the LEDs were coming on sort of told you that it was going to a failure mode. Now, on this slide here, what I've done is I've really taken the extract from a service bulletin which was issued January 10th, 2007 to the authorised Marantz repair specialists. Marantz actually made a change. So the original 4-bit micro, which is the 47C200BN, was actually replaced then by an 8-bit micro. And this 8-bit micro, depending on whatever firmware was flashed into there, you know, it was also commonly used, the 8-bit, on the 8200 amplifier as well. But here's the issue here. We knew that we had a defective microprocessor, and if I go online, you can still buy these microprocessors if it's the 8-bit version. What you cannot obtain is the 4-bit version. And as you can see here, it says important amplifiers with a serial number range beginning with, and this amplifier actually was in this category. So I couldn't utilize an 8-bit micro. I had to go and source a 4-bit micro, and luckily I was able to source a new old stock. I'm just sort of highlighting it. Just be aware that you are going to maybe purchase a replacement micro on a number of the supplier websites. What it tells you is this 8-bit micro is fully compatible with the 7200. True if it's after the date codes that you see here. So that's why I mentioned the serial number on the back of the amplifier previously. So once we'd sort of done all of that work, i.e. we had done all the reflowing of the circuit boards, we'd fixed the issue with the micro, and then also replaced the 2 speaker protection relays. The next thing that we have to tackle here is the alignment of the amplifier. So the first thing that we're looking at, and again I'll step through a number of photographs in a moment just so you can sort of see the multimeter and what the measurements are. We have 3 adjustments to make per channel. So the first one is that you would leave the amplifier normally running for about 15 to 20 minutes with no speakers connected, no inputs connected, volume control at minimum, and then all of your user controls at midpoint. And I connect my multimeter to the back of the first set of speaker terminals, but just make sure that system 1 or system 2 push button on the front is switched. Otherwise the speaker protection relays will not have energized, so you're not going to be measuring any DC offset at all. And then what I need to do then is to adjust the preset, and what I'm looking to do here is to get it to as close as 0 millivolts as possible. But you have a tolerance. As long as it's plus or minus 10 millivolts, that's within what Marantz deem as the factory specification. And then once that has then been done, the next thing that I'm going to be doing then is I'm going to be connecting across the emitter resistor on the respective channel. And then again from the front, I just make sure that it's selected as AB mode. And then I'm going to adjust the bias then until I have a reading of 8 millivolts with a tolerance of plus or minus 3 millivolts. And then finally, I select Class A mode, and then you'll see that the bias will increase quite dramatically. And I'm looking to adjust it then until I read 90 millivolts. But again, we have a tolerance here of plus or minus 5 millivolts. Now, with the amplifier, what you have are single-term preset potentiometers. So they're a little bit twitchy. So what I do here with the amplifier depowered, I just squirt some De-Oxit. I just rotate them backwards and forwards, the presets, just to clean the carbon tracks and return them roughly to the same position that they were before. So here you can see that we're measuring on the rear terminals. You just make out the multimeter leads. And we have a reading of 12.47 millivolts, so it's a little bit high. And then once we've made the adjustment, you can see here we're way down now to 0.12 millivolts, which is great, well within the tolerance. And then here you can see we have the AB mode. We've got this roughly to about 18.28 millivolts, which is perfect. And then when we come to measure the Class A mode, you can see here that we're well over 200 millivolts. And again, what you'll tend to find is on this amplifier, because it has an EI type transformer, you'll hear some low level buzzing noise because you can hear the amount of current which is being drawn, and that's the load on the transformer. So what I need to do then is just to make that adjustment, and you'll actually hear the tone of the transformer fall as we make the adjustment to bring it to approximately 90 millivolts. So here we're at 88.83 millivolts. I'll leave it to stabilize and then make the final adjustment. But just take your time to do this. It's not something you want to be rushing. And then once you've done the first channel, you can do the second channel. And then what I do is I'll leave it probably for about an hour, and then I'll come back and then just do the final adjustment again. And then here, when we look from the top, looking into the amplifier, you can see all the circuit boards are now clean, no more dust. And as we said, we carried out all of the required work. From a functional point of view, we've reinstalled the reliability back onto the amplifier, and all being well, it will deliver many, many years of trouble-free operation and listening pleasure then to the owner. So here we show the fail component parts. So what you can see here is the speaker protection relays, and then you can also see as well the microcontroller. And then the only thing to do after that was just really to put the amplifier into test mode, and the amplifier ran probably for about 2 or 3 hours. Everything was good and it was working perfectly. So that sort of brings us to the end of this repair tutorial, and if you need any guidance, support or assistance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any support that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.